Okay, we will join.
by
Okay, ठीक
1:50.
है. Okay.
So the fourth
All the
technical session
participants are requested to join at
by 1:50.
1:50, 1:45, 1:50. Okay. Thank you so much.
Okay,
Again.
thank you. Thank you.
ହେଲା ତାହେଲେ ଏଇଟା effective with less side effects
Hello, sir. Khare, sir.
Yes.
Sir, can we wait for 2 minutes? Audhya madam is joining.
Yes. Sharma sir has joined or what?
Yes, sir. Yes, sir.
Sir, namaskar.
सर नमस्ते नमस्ते
Namaste. Sir, after invited talk, the oral presentations will be delivered by the participants and among with Ayush Khare sir, Vinod Dubey sir from Government Science College, he will also judge the
Okay.
oral
Sure.
presentation.
Thank you.
दुबे सर
हाँ हेलो जी सर।
यस सर नमस्कार
नमस्कार सर नमस्कार।
अवधिया मैडम ट्राई कर रही हैं बट वो ज्वाइन नहीं हो पा रही हैं, कुछ टेक्निकल इशू आ रहा है। 1 मिनट देख लेते हैं सर। Sir, madam has joined.
Okay. Good afternoon. Ayush Khare sir, welcome as the chair
Thank you,
session.
madam. Thank you.
And our speaker, Dr. MP Sharma sir, also joined. Welcome to the national seminar.
थैंक यू मैम थैंक यू
Shall we wait for some time for more participants to join in?
या
Okay, so विनोद दुबे सर ज्वाइन कर लिए या नहीं अभी?
हाँ मैं आ गया हूँ मैम।
अच्छा अच्छा ठीक है। सो चेयरपर्सन से आप परमिशन लेके शुरू कर सकते हैं। आयुष खरे सर बताइए, अभी 16 ने ज्वाइन किया है। वी एक्सपेक्ट एटलीस्ट 30-40 पार्टिसिपेंट्स टू ज्वाइन इन। सो
So
क्या शुरू
what
करें?
we can do, we can allow Sarma sir so that during the talk students can
हाँ,
still join.
okay.
That will be otherwise
Okay,
things may delay.
okay, ठीक
sir,
है।
yes, sir.
Thank you.
No
Thank you.
problem.
So Bhargavi, please start. Okay.
So, good afternoon, all of you. We are in the fourth technical session of 2 days national seminar on advanced materials and characterizations 2022. On behalf of organizing committee and on my personal behalf, I would like to welcome the chairperson of this technical session, Dr. Ayush Khare, Associate Professor, Department of Physics, National Institute of Technology, Raipur. I also welcome our resource person for this session, Dr. MP Sharma sir. He is Assistant Professor, Department of Physics, Guru Ghasidas Central University, Bilaspur. I also welcome the judge of this session, Professor Vinod Dubey. He is Professor, Department of Physics, Government Nagarjun PG College of Science, Raipur. And finally, I also welcome all the participants and especially the research scholars who are going to present their research work in this session. So without any delay, I would like to hand over this session to Khare sir. Sir, it is over to you now.
Thank you, Bhargavi. A very good afternoon to you all. In this fourth session of NSAMC 2022, we are here with resource person Dr. MP Sharma. So let me first introduce Dr. Sharma, and after Dr. Sharma has delivered his talk, there will be 4 deliberations by research scholars. A total of 8 oral talks will be there. Okay, so those are who are enlisted in the list, they are supposed to be stay here for whole time. And also this is our request of organizer always, that though it is an online event, but you have to be here for entire session so that you can get benefited. Okay, so we are privileged here to have Dr. MP Sharma from GG University, Bilaspur as a resource person this afternoon. Dr. Sharma is presently serving the Department of Pure and Applied Physics, Guru Ghasidas University, Bilaspur since 2010, and he obtained his MSc from IIT Bombay, and then later he obtained his PhD from University of Rajasthan, Jaipur. He has successfully qualified this NET and GATE exam. And he has published more than 22 journal articles and 16 articles in the proceedings of international conference and national conferences. Doctor has also participated in more than 25 international and national conferences. So on behalf of organizing committee, I would like to invite Dr. Sharma for his for sharing his views. Dr. Sharma.
Okay, thank you, Khare sir, for giving this kind of opportunity, and also thanks to our convener and Madam Bhargavi Madam and his team to organize a national seminar on advanced material and characterization 2022. Is my voice is audible or not?
It's fine, perfectly all right.
Yeah, okay, then. So I'm sharing my PPT. So I think this is visible. Okay, so today I'm going to talk about the ferrites. Ferrite means as a synthesis, characterization and applications. So today I will cover the background, properties, classification, synthesis, characterization of ferrites and perovskites using a different techniques. So today's the research on the oxide. Generally oxide is a lot of types, but we have taken here is 2 types. okay, as a ferrite and the perovskites. Okay, also is a ferrite is considered as a ceramic. So moving fast moving over there, growing age in magnetic shielding and magnetic biosensoring and magnetic recording devices and information storage, mobile communications, electronic devices, also is a medical devices, transformers, and pollution control. And there are a lot of use of the ferrites and we can say the oxides. So generally, the magnetic ceramic are made of the ferrites, which are the in the nature as a crystalline minerals, as a composed of the iron oxide, in the combination of the some other metal oxide. So there are the general formula of a ferrite and the perovskites is given by Ab2O4 or and AbO3. So generally in a ferrite Ab2O4, so there is a B for a iron, okay, and A is a sum of any metallic. Okay, so the most of familiar ferrite is magnetite as a naturally occurring ferrous ferrites, which is given by Fe2O4. Okay, so commonly is known as a landstone of this one. So generally the magnetic property of a magnetite. Magnetite means generally it is considered as a perovskite size, LMNO3. So have been explored in compass in the ancient times. So the magnetic behavior shown by the ferrite is called the ferrimagnetism. So it is quite different from the magnetization. It is called the ferromagnetism, and it is exhibited by the metallic materials such as iron, you can say. Okay, so there is a in a ferromagnetism there is a one kind of the lattice sites and unpaired electron pair. So in a ferrimagnetism, on the other hand, there is a more than one kind of the lattice site and electron spin aligned so that it is opposed to each other. Okay, sometimes it is called the spin up and sometimes it is spin down. So this is a cancel out to each other. So now we can say the complex or mixed oxide can be classified as a oxide grouping or two more different cations. So you can say is a mixed oxide or complex oxide. So oxide considered as a single cations in a different oxidation states. Also is classified as a mixed oxides. So the most typical structure of the mixed oxide consists simply of the two or more cations with a different oxidation states or as a ionic radii and also as a coordination numbers. So diversity in the properties come from the structures as well as the bonding. Okay. So we can compare the different properties of these simple oxides like a ferrite. Ferrite means Ab2O4 and AbO3 like this one. So now generally we have to be classified the ferrites in three groups. One is called the spinel ferrites, another is garnet, and another is a magnetoplumbate. So the spinel ferrite is a cubic, like is a Fe2 means that there is a cations as the second oxidation state and the iron Fe2O4. Another one is a garnet is cubic and the oxygen state is 12. And another type of this one is the magnetoplumbate. Right? The structure type is hexagonal and it is written by as a Fe12O19. But we are generally talk about the spinel ferrites. So introduction to the transition metal oxides. Okay, so in the transition metal oxide, continuously probably one of the most interesting class of the solids. Okay, so it's a very different type of the structure properties and some of magnetics and some of the electric properties and so on. So the nature of the metal oxygen bonding is vary between the nearly ionic to highly covalent bond, and the unusual property of the transition metal oxide are due to the unique nature of the outer d shell electrons. So we find the oxide with the metallic properties like a ruthenium oxide, lanthanum nickel oxide, and so on. And another one is a barium titanium oxide that is classified as a perovskites, and it is a nature in the insulating behaviors. So there are also oxides that are the transverse both these regime with the change of the temperature. Also is a pressures, also is a doping, and also it shows a very interesting electronic property which are arising from the charge densities, charge ordering, and some of defect in a oxygen, also as well as the some of the impurities we can say. So oxide with the diverse of a magnetic property. Okay, it is from the ferromagnetic and antiferromagnetic. Also is a many oxide is a switchable orientation state in the ferroelectric and ferroelastics materials. So transition metal oxides constitute one of the most interesting class of the solid as a variety of the structure and properties. Also, it is a rich behavior of the interaction between the charge, orbital, spin, lattice degree of freedoms. Okay, so now we are going to talk about the structure of the ferrites. So structure of the ferrite, it is a cubic type. And the general formula of this one is written as a, we already says Ab2O4, where is a means is divalent metal ion, such a zinc, Fe2 plus, Mg2 plus, Mn2 plus, and so on. And B is taken as a generally as a iron, and we have to be doped with the iron side as well as a side. So that is defined as A and B sides. So therefore, in a ferrite unit cell, there are the 8 divalent metal ions. Okay, and there is a 16 ferric ions and 32 oxygen ions situated in this one. So generally, again, is a ferrite is classified into 2 categories. Okay, one is called is a spinel structure, another one is a inverse spinal structure. So, in a regular spinal structure, it is defined as a AB O4, where is A is a divalent ion and B is a Fe2 3 plus O4. Okay, so this is a regular spinal ferrite. And next one is a inverse spinal ferrite, which is gives us some mix up of the A site and B site, which is A site is a iron 3 plus and B is a some of divalent ions and irons also. So on the basis of this structure, the magnetic property will change. So generally, we have to be calculate the magnetic property using the this structure. In generalize, if we take the Fe and Fe2O4, or we can say the Fe3O4. This is also is a type of the inverse spinal, which is give the orientation of the spin is a up, and Fe2 is a down, and again is a Fe3 plus is down, and resultant it is give the 5 plus 4 1 is a 4. So this is an anti-parallel and parallel combination, or you can say the interaction between dominant to net magnetization of a ferrite is given by in a unit of the Bohr magnetron is a 4 mu B. If you take another examples of the ferrite is nickel oxide Fe2O3, that is in a structure type the inverse, and the iron is situated at the site of A, and another is a B octal side. So magnetic moment of the Fe3 plus is 5. This arrow is indicate the up, and the nickel is a downward, and again is a iron 3 plus is downward. So net magnetization is given 2 mu B. That is the per molecules, and similarly we have to be understood the structure or the site occupancy is the resultant magnetizations. So now another type of the structure is a Perovskite type structure. So in the Perovskite structure is given by AbO3, varies. A and B are two ions. Okay, in a ferrite there is a Ab2O4, and in perovskites it is AbO3. So in a perovskites, A and B also is a two ions, generally having a different size. And O is a oxygens, and if you are looking, the structure of this one is again is a cubic. Ferrite also is a cubic. Okay, but there is only depend on the A and B. Okay. So the A atoms are generally larger than the B atoms. So B, it is situated at the center of the cube, and A is at the center of the corners, and oxygen is situated at the base of the cubes. So generally it is considered as a cubic structure of this one. So due to this structure, there is a very stable structure and large number of compounds, variety of the properties. Many practical applications are there for due to this structure. And another key role of this one is a BO6. That's the site of the octahedral, which is give the ferromagnetism and switching in the ferroelectricity. Extensively, the formation of the solid, it is used optimization using the composition, and we can say the phase diagram and so on. So now next one we have to be discuss about the LaMNO3. LaMNO3 also is called the lanthanum manganites, which is substituted at both the side of the LaMNO3, means AbO3. So A is considered as a lanthanum, rare earth, and B is a Mn side, which is give the considerable attention due to the interesting phenomena. It is give the negative magnetoresistance. Where is the magnetoresistance defined as when applied the magnetic field, then the resistance will be increased or decreased. Generally is resistivity is decreased, so it is defined as a GMR or MR, magnetoresistance. So it is he also is a magnetic property, structural and metal insulator phase transition at the due to the charge following ordering. So large number of studies have been made on the system obtained by the lanthanum by divalent cations like calcium, strontium, barium, and some of these are there. So there is a result in the important result is that when La is substituted by 1/3 atomic, okay, 1/3 atomic, or you can say is a 0.33. So or more divalent cations like a calcium or strontium, the system attain a long range ferroordering, or you can say the metal insulator transition. So this is explained in the term of the double exchange. So double exchange is given by or described by the Zener, which is the electron hopping between the Mn3 plus to Mn4 plus. So in the case of Mn plus 3, there is a two spins are there, and in Mn4 plus it is a spin, single one spin. But when you are hopping means transferring the spins from Mn3 to Mn4, and it is give again is a up direction. That is called the ferromagnetism. Okay, so this is the concept is introduced by the Zener, and it is defined as a double exchange. So it is transfer electron from Mn3 plus to Mn4 plus, and Mn4 plus to Mn3 plus. So if a d electron of the two manganese ions are parallel, the configuration of Mn3 plus oxygen and Mn4 plus and will be degenerated, and another one it is give the ferromagnetism. Okay, the same case, but it is the spin is canted with the sum of angles. Okay, so resultant it is give the ferromagnetism. So now next one, we have to be classified our perovskite structure using the tolerance factor, which is given by Ra plus R, or whereas under root 2 Rb plus R0. It is for a cubic structure. Okay, so when a structure is stable, it is 0.89 to 1.06. Generally, when it is close to 1, then it says it is perfectly is cubic. So if A is a small ion, then it is tolerance factor is less than 1, and tetragrammaton maybe is due to this some structures. So now next one is another type of the perovskite is given by this one. This is called the layer perovskite compound. Have a general formula is a AnMnO3 Tn plus 1. In generalized case, it is given by n is equal to 2. Then it is bilayered magnetite. There is a one single crystal, one perovskite structure, AbO3 type, and then again have to be layer structure. So it is considered as a double layer of the Proscates structure also. So this type of the compound have a two quasi-dimensional amino network. Means we can say the double exchange structure is a two-dimensional in a x direction and in a y direction also. So also is a important class of the mixed oxide based on a Proscate structure is given by AbO3 and a spinel structure like this one and another structure. These are the oxide form structure is given by different notations. So now there is some special type of the Proscates. One is barium platinum oxide, KNOBO3, and so on. So this is LiNOBO3 is a ferroelectricity and focal effect, piezoelectric and photoelectricity and only optical polarization is source. Okay, so now why we have to be going for the Proscates compounds? That they can be synthesized using a extremely wide variety of the combination of the chemical element due to several reasons. The first one is a Proscate structure occurring with both the sides A and B sides and distortion between the structures as a cubic or anything or cations of the different sizes. The structure is remarkable tolerant of the vacancy formation and atomic scale growth was to the structures. So now some of the application of the Proscates is given here. So AbO type structure type oxide displays a wide spectrum of the physical properties, technical application, and some of the ferroelectricity, antiferroelectricity, and so on. The ferroelectric property are mostly controlled by the relative size of the ions, and the electric and magnetic property are mainly depend on the electronic configuration, or you can say the electrons. So dopant and the substitution have a profound influence of the property of AbO oxides. So these materials are used in especially ceramic capacitors, also in a piezoelectric, some of switching devices, and some of the superconductors and also. So now what is a ferroelectricity? We are not going about this one, and this is a ferroelectric material which will develop the spontaneous polarization, same like as a magnetization. We have to increase the field and give the. So I'm skipping this one, and we are coming from the basically we have to be prepared methods. So synthesis techniques are there. So there is a lot of techniques to synthesize the ferrite and Proscates. Generally, you have to be considered some standard technique, plus combustions, coke distribution, sol gel, citrations. All are things you have to be taken as a raw materials and you have to be processed at a different temperature and different physical properties and so on. So we can classify it. Another is standard ceramic and coke distribution, sol gel, and citration. So if you are talk about the sol gel synthesis method, in the sol gel process, a chemical route for the low temperature synthesis of a single or multiple components material in the form of powder, or you can say is a ultra fine powders. So sol gel is a multi-stage process involving as a chemical and physical process with the hydrolysis, polymerizations, gelation, condensation, drying, and so on. So in a sol gel technique, materials are obtained in a sol gel technique, materials are obtained from a chemical solution via gelation. So we have to be say is a sol gel. So there is a two type of the routes. One is a metal organic routes are there. So we have to take in this one as a metal oxides in organic solvent, and the inorganic routes with the metal salt in the aqueous solution, chloride solution, oxochloride or nitrate form. We can take this one. So in the sol gel, we have to be take any solution material and dissolve all the raw materials and heat and then to be processed. Now another is a coke precipitation method. Also it is similar like the sol gel. So this simplest method and convenient to synthesize the magnetic particles. So in this method, a uniform composition is obtained by the precipitation reaction of the two or more cations. So this is involve the 4 steps. One is a nucleation, another is a growth, fluorescence, and agglomerations. In the co-precipitation method, the precipitation is conducted by the adding a mixture of the solution like a chloride of cations, and drop wise we have to be dropped as a NaH or sodium carbonate solutions, so we can control the pH one. Okay, using the sodium chloride we can control the pH, and using the pH we can control the particle size also. If you are talking about the nanoparticles, then you have to be considered. Otherwise, another factor, it is very important, which is temperature. So in the co-precipitation method, generally you have to be need 500 to 900 temperature for 3 hours to 5 hours or 8 hours, depending on the raw materials. In a ceramic methods, we have to be conventional ceramic method, which is synthesize the variety of the materials as a ferrite or as a perovskite, or so in this one we have to take as a oxide forms, is MnO2, FeO2, and mixing in using a pellet and mixing in a mixing and then make a pellet and synchronize in the temperature. But for a ceramic, there is some drawbacks. You have to be need the higher temperature, which is melting the compounds. So generally, it is considered as a 1200 temperatures. So in general reaction, the slow rate, but is a increment that of temperature faster, and the reaction as a diffusion rate is increased until the solid form does not reach the melting points. So the property of the ferrite are mostly depend on the processing. Processing means is a synthesis and preparation of the fine or uniform powders, which is the minimum particle agglomerations is a challenging task. So in a standard ceramic, there is some of impurities are there because of the required temperature is not there. So there is some drawbacks are given here. So sol gel, it is a low processing temperature, and there is a disadvantage, is a low yield, evolution of the large amount of gases, co-preparation is incomplete. If you are incompleted, then your compound is not properly in a scattering, and the combination, that is the evolution of the large amount of this one. And so there is another methods also, is the microemulsion and microwave and so on. So now take our study. So there is a sum of properties we have to be modified using the synthesis rules. If you take the different synthesis, maybe the properties are different. So there is a lot of reasons to behind this one. Another one is doping. So it is isovalent, it is a heterovalent, or the valence compound, whatever you have to be chosen. Also is affected is a sinking temperature, also there is a time, cooling rate also is depend, and some of the purity and particle size. If your particle size is different, then it is a property is slightly different. So now next one we have to be prepared some of the ferrite. One is called the cobalt ferrite. In the cobalt ferrite, we have to be substitute cerium. In the formula is the CO, C, Fe2, 2 minus 1. It is a iron side, we have to be of the cerium one, rare earth. There is 2 samples we have to be prepared using the solid state reaction. In this one, we have to be take a cerium oxide, iron oxide, and cobalt oxide, and mix and heated at a 900 degree temperature, and we have to be measure the XRD. So these are the XRD pattern, which is shows some stars here, which is give some impurity of a cerium oxide, CO2. But CO2 is not a magnetic, so only the magnetization comes from the CO, Fe2O4. There is a hysteresis curve at a low temperature 10 Kelvin, which is measured at the University of Rajasthan, Jaipur. So now this is the Raman spectra, which is gives the sum of bands at a 600 centimeter and low is 400. This one it is represented as a tetrahedral and octahedral in a spinal structure. So these are the some elemental. Another one is a sodium doped perovskites. Okay. So now this is the sodium one. It is given by AbO3 type structure. So in the sodium is doped perovskites. So the aim of this one is to support the finding the based on the study of the divalent cation substituted at a LMNO3. Okay, so when you are going to be long range for FM order, or you can say is an insulator metal transistor, shows up a system with the more than 1/3 atomic fractions. Means up to 1/3 there is some disordering are there, but after this one it is shows a ordered. So 1/3 atomic fraction substitution by the divalent. So we have to be substitute a monovalent. The sodium is a monovalent, and now we have to be check that this monovalent system it is give at up to 1/6 doping. Means this is 1/3 and this is 1/, because of the this one is a monovalent and this is a divalent, so maybe is a 2 times. So 2 times means a half of this one, so is 1/6. So when you are saying when you are checking this one, this is the XRD pattern of a sodium 0.1. Okay, so this is shows a purely crystalline in a nature, and the latest parameter is given as a 3.88 angstrom, and is merely is a pseudo-cubic. Pseudo-cubic means you can say is a another type of structure, but it is considered as a pseudo-cubic. Pseudo-cubic means there is some alpha angle is there, so it is slightly tilted, like a 89.9. So it is slightly this one. So this is the magnetization we have to be taken for a both of the sample 0.1 and 0.2. 0.1 doping, another is a 0.2 doping. So this is shows as a ZFC and FC. ZFC means is there is a zero field cool, and another is a FC, is a field cool. Means first we have to be apply the zero field and cool down the sample up to 0 Kelvin, or there is a facility to cool down at 10 Kelvin. So we have to be insert the sample in the cryostate, and we have to apply the zero field, exactly zero field, and cool down the samples, and then take the and then apply the field and taking the measurement in the warming cycles. So this is give the nature, and this is the field cool, means when we have to apply the field and then cool down the sample and then take the measurement in the warming cycle. So this is a ZFC and FC. If you are looking both of the samples, one is a difference between the ZFC and FC is more, and in this one is very least compared to the 0.1. So sodium 10, that is the shows a metal insulator transistor, or we can say is a ferromagnetic to paramagnetic transition. In a sodium 20, that is shows a metallic state between 20 Kelvin to 295 Kelvin. There is a 295. This is a ferromagnetism. There is no deviation between. There is almost is a sum of magnetic moments are there. But after that one, the magnetization is comes to be down. So in a sodium 20 shows the metallic state between the this temperature would go over to the insulating state only above 300 Kelvin. So simply sodium 20, or we can say is a 0.2, shows a metallic state between okay. So another observation we have to be take as a pH curve, or it is sometimes called the MH curve, magnetization curve, between the field versus magnetic moment, which is given at a different temperature. One is 0.1, another is for 0.2. So for a low temperature, another is a room temperature. A and B, it is a is for a room temperature, another is a low temperature, 20 Kelvin. Both of the samples you have to be taken at the room temperature and 20 Kelvin. So in the effect, the sodium 10, the saturation factor is much less than in the sodium 20, which is agree with the inference of the sodium 20 having a ordered FM state against the disordered sodium. So we can say using this magnetization, okay, at this point it is a ferromagnetic, but in this at this one it is a nearly, but there is a system is ordered. Now we have to be another measurement we have to take as an electrical measurement, which is made at the TFR Mumbai. So this is for a sodium 0.1 and another is a 0.2 at a different field. One is a 0 Tesla, 1 Tesla, 5 Tesla and 9 Tesla we have to be taken. So when you are increase the field, okay, so resistivity again is decreasing. So we can define there is some magnetoresistance are there. So in 20 it shows a metallic state between 22 to 95. Okay, so this is the metallic. Because your resistivity is increased with the temperature is increasing. But in this case, it is a sodium, it is a phases, and the low temperature it is decreasing, again is increasing and then decreasing. So sodium 10 shows a metal insulated transistor at 20 Kelvin. This is much below the temperature where the system would be PM to FM to PM transistor, means ferro to ferro. These are the FM to this one. So now we have to be fitted the electric property, electric transfer measurement again. So this is we have to be fitted and then calculated the MR, magnetoresistance, which is gives a different one. So at a 9 Tesla, it is a higher one. It is give the 60% at the low temperature, and at the room temperature, it is give almost 40%. Okay, when you increase the field, the MR is increasing. And we have to be fit the Poulin equation, which is given by rho 0, rho 2, T square and rho 4 in a low temperature range. In a low temperature range. So this is the this one equation. It just shows the some contribution from samples. So rho 0 it is defined as a contribution to the resistivity from the grain boundary, and rho 2 it is given as a electron magnon scattering, means we can say the spin views, and rho 5 it is a rho 5 it is give the electron magnon this one, and rho 0 is nothing, is a contribution to the grain boundary, and rho 2 is a electron scattering. So from these parameters, we have to be fitted and okay, conclude the increasing the field enlarge the magnetic domain, which is caused by the cause rho 0 to decrease. The reduction in this one, it is increase the field, also the decrease the spin fluctuation. When you are increase the field, the fluctuation between the spin it is decreases because of field is very high. So now magnetic and electric observations show that the sodium 20 is a FM ordered and metallic. So this would be implies that the 20% sodium substitute sample, there are the sufficient number of double exchange pair to enable the long range FM ordering, which is we have our aim to observe this one. So in a sodium 10, the system number of double exchange pair is not enough to release the long range property effects. So now so these inferences support the finding the based on the study of the divalent cations. Means in LMNO3 we have to be shows by if you are substitute with divalent cations implies as a sodium monovalent cation, that is give the fraction of 1/6. So this is coming to the effect of the magnetic field. The sodium 10 shows a metal to insulated transistors. Points shift to the high temperature with the increasing the field. This is understandable. The increase the field causes the magnetic domains to enlarge and making the magnetic state more order, which is the metallic region, or we can say and the higher temperature. So if you're looking the measurement, so in both of the cases, in a 0.1 and 0.2, one is increasing the TC. So now another one, cerium substitute. Hello. Okay. So now next one we have to be prepare another samples like a cerium substituted process, means LaCO CmNO3. Again we have to be take a rare earth one. So in this case, in a sodium case, there is a sodium is monovalent and the cerium is a trivalent as well as a tetravalent. Okay, so maybe is a double exchange effect is maybe is increase or decreasing depend on the cerium or Mn, or maybe is a doping limits. Okay, so there is a some this is the XRD, but in the same situation, there is some of impurities are there. Okay, when you are increasing the doping amount, the impurity is increasing because of the peak of this impurity site is given higher. But again, the CO2 is non-magnetic, so there is no effect in magnetization. So there is a magnetization comes maybe CmNO3, where is a C is 0.5, 0.05, 0.1, 0.2, and 0.3. So in a cerium substituted, we can conclude, or we can say these all the samples again it is shows the PM to FM states. Okay, these are the systematically ordered systems, and it is going to be PM, means this empty curve also shows recorded in different fields, which is again is the ZFC and FC we already defined. So if you are looking 0.5, x is equal to 0.05, the system is more disordered compared to the 0.1 and 0.2 and 0.3 because of there is a deviation between the ZFC and FC curve. There is a lower one, but in the 0.5 there is a more than one. So we can say is a 0.05 is more or disordered. Again, it is again increasing the point where the increases the disease, which is first one. This one it is give nearly is 265 around. Another one is 280 and another is 285 and so on. So TC tend to increase the C content, but the nearly level is 20%. After that one, it is almost as constant. And ZFC and FC curves depart from each other is right from the temperature where is a FM state is source. FM state is source, and after that one, the PM states. So now this is a MH curve at room temperature. Another is a 20 Kelvin for the 4 samples. So these are the absence of the hysteresis at the room temperature, which is state that is a paramagnetic states. At a 20 Kelvin, the sample shows some hysteresis indicative the ferroelectric behavior. So hysteresis parameter in all the 4 composition are quite small. So these are the suggestive of the soft FM state. Means on the basis of this one, you can say is the material is a soft magnet. So now again there is some of electric transport property measurements. So again it is a measure at the TFR at low temperature from at a different field, 0 Kelvin. One red one, it is represent for a 0 Tesla, and green one is 5 Tesla, and blue one is 14 Tesla. So all the sample shows the peaking behavior, means insulator to metal transistor, and we can calculate the PC in the absence of the magnetic field, without the field. So ratio it is very high at the higher field, so it is give 140. Another one is 217, then 240, and next one also with the same as there is no change. So maybe this not changing as the reason is not properly is prepared the samples, or whatever reason is there. So we have to be calculated the MR at different field. So magnetoresistance for all the samples we have to be considered, and the maximum is 40% in the 5 Tesla and the 60% of the 14 Tesla. At the 300 Kelvin, and under the 5 Tesla, it is close to be 10%. In a low temperature, the MR is higher. At low temperature, room temperature, it is lower than, it is decreased from 60 to 20% in the case of different samples. So now conclusion we can see. So we have to be prepared some of the serum substituted ferrite as well as the perovskites, and see the as for synthesis, we have to be successfully prepared, and we have to be successfully prepare the samples. So thanking you. These are our color.
Thank you, Dr. Sharma.
Yeah, sure.
So now the session is open for discussion. Any queries, please, from audience end? Participants are requested to get involved in a better way. So for that you have to be here, and you have to get your queries addressed. Anybody with any question from the participants? How many participants are alive here? Academically alive.
That's very important. That is very
Right?
important.
Because paying fee and getting certificate, this has become the custom.
Yeah.
Any question from you participants?
So maybe this topic is not too familiar to them, because light is a new.
Yeah, maybe it's there.
But science is familiar, and science is like familiar to everyone. Science and physics. But in a slide of say 50 or 40 slides in a presentation, there can be hundreds of questions. But for that, you have to be vigilant. You have to be involved. Okay. So, Dr. Sharma, thank you so much for this nice presentation. It was really
Okay,
informative, but somehow due to non-involvement of participants or their being from the different fields, no queries.
Yeah.
I have a query like, for example, as you have mentioned in the beginning that perovskite materials are there. So recently we are working on perovskite solar cells. But when we see that it is difficult to fabricate perovskite solar cell with good stability, this is what we find. But you have said that they are stable. So how this can be like? This is not a controversy, but this is fact. Like when they are prepared as a material, they are good in stability. But when they are used in a cell, there can be some difficulty in getting their longer lives. Right. So would you like to throw some light on this?
As per application wise, I have no idea about this one, but maybe you can use the different techniques. So we can try it to better optimize. Okay. So if you are using a sol gel, maybe some oxidation is there, or maybe some impurities there. So we have to be try to different techniques. Then we can optimize using this one. I think so. But as a structure wise, you can say it is stable. But for application wise, maybe some changes on the surface or whatever there. Okay.
Okay. Thank you so much. Thank you so much once again on behalf of the entire organizing committee. I thank you all for your for being here and sharing your knowledge with all of us. Thank you so much.
Thank you. Thank you.
So after this expert talk, I would like to request all the participants for the rest of the session to be ready with their presentations. They will be given a total of 10 minutes, where 8 minutes will be for delivery and 2 minutes will be for discussion. Right? And the participant will be judged on the basis of their innovation of work, their presentation skills, depth of understanding, the way they address the queries, and how they manage the time. So these are the parameters on which the participants will be judged. So in this series of a total of 8 presentations, let me invite Mr. Piyush Jha for his presentation, oral talk, on the topic visualizing the process of material destruction using mechanoluminescence techniques. Piyush Jha.
Yes, sir. Good afternoon, all of you. I am Dr. Piyush Jha, and I am presenting an oral talk on visualizing the process of material destruction using mechanoluminescence technique. The mechanoluminescence is a luminescence phenomena induced by mechanical action such as compression, tension, friction, or torsion. Here we see the example of mechanoluminescence of sugar crystal, triboluminescence of tape. Triboluminescence is due to rubbing or separation of two solids in contact. Figure 3 shows the recording of pressure with velocity simultaneously during the writing by pen through mechanoluminescence.
Your slides are not changing.
1 minute, sir. Changing. 1 minute.
Okay. So this is the second slide, or earlier slides were also there? Some other slides were.
Stop sharing your entire screen. So it is visible?
Not yet. Yes, coming up. Go to second slide. After
Yes,
introductory slide, you start with second slide.
Second slide. Okay, sir. Here we see in figure 1 the mechanoluminescence of sugar crystal, and figure 2 triboluminescence of tape. Triboluminescence is due to rubbing or separation of two solids in contact. Figure 3 shows the recording of pressure and velocity simultaneously during the writing by pen through mechanoluminescence technique. Figure 4. The mechanoluminescence produced during touching the screen of mobile, which is coated with mechanoluminescent film. Mechanoluminescence due to compression of plastic disc coated with mechanoluminescent film and their MATLAB processing image. Our group reproduced this experiment at NIT Raipur. Now I tell you something about the research motivation behind it. ML sensors have been used in practical application such as bridge, building, welding points of pipeline, and a structure health monitoring system to ensure the reliability of a structural material. It is important to understand the damage generation, progress process, and fracture mechanism. For the damage generation and its behavior, there have been some reports which are limited to the damage assessment before and after static and dynamic stress analysis. If the damage generation and its behavior can be visualized during the mechanical testing, it can contribute to enhance the performance and ensuring the reliability of product. Therefore, an in-situ evaluation technique which can provide a dynamic stress-strain distribution and track fracture phenomena has been strongly demanded. Now the figure 6 shows the schematic diagram of the experimental setup for studying the material destruction process. In this experiment, the ball is dropped from a particular height on the glass plate coated with mechanoluminescent film. The digital camera is situated below the glass plate. In the present study, the commercial European doped strontium aluminate phosphor is used. An ml paste consisting of a mixture of European doped strontium aluminate powder and epoxy resin is directly coated on the surface of the glass plate of thickness 1 mm by screen printing method and cured to fabricate an ML sensor. The screen printing method provides a homogeneous dispersion of European doped strontium aluminate particle and a uniform thickness of ML sensor on glass plate. The thickness of the ML sensor film is 0.3 mm using Uzuki dial thickness gauge. In this study, the ML experiment was performed in a dark environment at room temperature. The ML images are recorded by Sony Alpha digital camera. The ML sensor was once irradiated by a blue light emitting diode of wavelength 365 nanometer for 1 minute and kept under dark condition for 5 minutes. When the steel ball of mass 66 gram dropped at height 50 centimeter, it creates a damage in the glass plate. In this experiment, we captured a fracture generation video by Sony Alpha digital camera.
Piyush,
This-
can you hear me?
Yes, sir.
You are on slide 7 or you have moved?
Yes, sir.
We can see slide 7 only. So you are still on that or you are ahead of that?
Yes, sir. In front of that.
7 you are discussing, right?
Yes, sir.
Okay, fine. Please continue.
Yes, sir. Result. The figure 7 shows the XRD pattern of European doped strontium aluminate phosphor, and the peak shows the presence of a monoclinic structure of sample. It is well matched with JCPDS card number 34030379. When the ball impacts on the glass plate, it creates intense ML area at the center. Figure 8 shows the snapshot of ML images of video recorded by digital camera. Here we clearly see the fracture generation in the glass plate. In frame 1, there is no fracture is found. In frame 2, a small fracture is seen, and in frame 4, the final fracture image is found. Figure 9 shows the gray image of ML created by the impact of the steel ball on a glass plate, and B shows the MATLAB processing images. Here two kinds of ML intensity area are found, higher and lower. The faster the crack separates, promptly more stress is produced. Higher mechanoluminescence intensity is found where the stress is high. How the intensity is changed during the fracture generation, which is revealed by the figure 10. In this study, we also found the best mixing ratio of European doped strontium aluminate phosphor and resin is 40:60. It gives the better adhesion strength at the interface between the ML sensor and the glass plate. If the adhesive strength is sufficiently higher than the fracture strength of the ML sensor, it shows superior tracking performance for fracture generation. And in conclusion, this mechanoluminescent film can be useful for the identification of crack generation in such materials. Through this ML sensor, we can visualize a small crack generation which is poorly visible with an unaided eye. And ML sensor able to detect potential destructions such as active cracks, real crack propagation, and mechanically weak points. Thank you.
Thank you, Piyush.
Yes, sir.
Any questions from audience?
May I, sir? May I, sir?
Please, who is there?
Vinod Jena here.
Okay, sir. Please, please.
You, sir,
Yes, sir.
in your illuminate, you have grouped the europium.
Yes, sir.
Europium in which oxidation state? +2 or +3?
+2.
Why not +3? Because +3 is the narrow band. And
Yes, sir.
+2
Actually,
is-
mecanoluminescence intensity is more as U2 plus as compared to U3 plus.
but it's so
We
broad
use
band.
we use the commercial phosphor.
But europium 2 will show broad peak as comparison to +3, which one is the narrow peak. So why is it is chosen for that?
Sir, my point is you say about in photoluminescence, but in mecanoluminescence we deform the sample. We have prepared a sample of U2 plus and U3 plus also. When we
Right.
measure the mecanoluminescence intensity, the mecanoluminescence is found highest for U2 plus sample.
U+2.
Yes, sir. U plus 2.
And which types of transition? I think it is a forbidden transition.
G. 4F5B.
Okay,
Yes.
thank you.
Thank you. Anybody else? Is there any question? So my question to you, Piyush, is this: what is the broader application? What are the broader applications of this phenomenon?
Sir, it is useful in structure health monitoring system and aircraft also.
Structural health monitoring means what?
Sir, in the building blocks and bridges and in aircraft body.
Okay. One more question. Go to your XRD patterns.
Yes, sir.
So as I can see, or as everybody can see, there are certain other peaks also, associated peaks.
Yes,
So
sir.
these are noises or what?
Sir,
Hello?
yes, sir. Yes, sir.
Like whatever peak you have assigned, there are some other peaks also, right?
Yes,
So
sir.
they
Yes,
are
sir.
associate peaks, or peaks
Sir,
can be
these are
ignored.
actually these are associate peak. I am not index the Miller indices. These are the well matched with the JCPDS.
Okay.
Yes.
Right. They also have some relevance, right?
Yes, sir. Yes, sir.
Okay. Anybody else? Okay. Thank you, Piyush.
Thank you, sir. Thank you, sir.
Next speaker is the group of next speakers is Chiranjeev Lal, Jitendra Singh, Pawan Kumar, Ramesh Katiyar, and they will be discussing on study of CDSE thin film on various substrate by thermal evaporation technique for photovoltaic applications. I think Chiranjeev Lal
Okay,
is
sir. Okay,
going
sir.
to deliver this. Okay. Please. So for some time you have to turn your camera on so that we can see you, and then you keep on presenting.
Good afternoon, sir. Please,
Very good afternoon.
I
Please
am
start.
visible.
Please start. Yeah, sure. Please start.
My name is Chiranjeev Lal from मैं research scholar from Department of Physics, KGK College, Malawat, affected to MJP Royal Government University, Bareilly. My presentation topic study CDSE, study the CDSE film on various substrates by thermal
Mr. Dharamveer, please turn your mic off.
photovoltaic application. CDSE introduction. CDSE selenide is a compound with the formula CDSE. It is the black to red black solid that is classified to second and sixth semiconductor for n-type semi-type. Much the current research cadmium selenide is focused on its nanoparticles. Nanotechnology application, energy for production and storage, optical electronics, medicine, electronics, water cleaning, sport goods, fabric, paints, optoelectronics, the technical load of electronic device that interact the light, which may be the visible, the infrared and ultrasonic spectrum region. Optoelectronics application, light emitting diode, optical fiber, photodetector, photoresistor, photovoltaic, laser diode. The spherical CDSE structure is unstable and convert to the voltage from upon the moderate heating. The transition starts about the 130 degrees Celsius and 700 Celsius incomplete within a day. In film deposition, a resistive thermal evaporation technique has been used to deposit CDSE thin film P-type silicon. A high vacuum chamber was used to deposit CDSE thin film. Ultrasonic chambers separate CDSE powder. Was the placed in molybdenum board is evaporated, which was kept the vertically distance of 1.14 centimeters from the substrate holder. Under a vacuum pressure greater than 10 to the minus 4 millibar, a CDSE thin film was deposited for 30 minutes at normal substrate temperature using the constant current of 60 ampere at a deposition rate of around 10 seconds. The thickness of film where the measured by stripe profile with value of
Mr. Chiranjeev,
sir.
You are explaining XRD, right? Because I am
XRD.
Okay. So XRD slide is visible.
XRD pattern of CDSE thin film, SI P-type separate, XRD diffraction photons were recorded in the 2 theta range of 2065. Identify of crystal structure pleasure and lattice planes for the observer diffraction peaks from the atomic flames of deposit thin film. The XRD pattern also the highlight intensity peak 002 at the 2 theta 25 23 another peak the observer at 44.58. As the substrate temperature increased from the 150 centigrade to 350 centigrade, a new peak a observer. The crystallicity of thin film also changed with the temperatures. Absorption and transmission study are carried out in the wavelength range 300 800 nanometer to investigate the optical properties of CDIC thin film. So the variation of absorption A and transmission T with the wavelength of a lower grain size, resulting in the increase in the scattering of photons at grain boundaries, called contributing to the decrease in transmittance.
हाँ बोलिए बोलिए सुन रहे हैं.
Energy band gap. Energy band gap. The optical band gap of the thin films has been determined from the absorption coefficient using the technical equation. The band gap CDIC thin film the range of 1.36 electron volt to 2.4 electron volt as p-type substrate. The surface morphology of ground films CDIC on SI p-type substrate analyzed by atomic force microscope AFM 150, 200, 250, 300 and for the 350 samples. It is the observer from the capture image which is the taken over the area of range of 3 microampere into 3 microampere that the particles are uniformly distributed on the entire surface on the thin film, and grains of CDIC particles were found to exist in the spindle shape. Highly electrical shape of the grains had narrow size distribution on the surface of thin films. Conclusion. The thin film of CDIC prepared thermal evaporation using the silicon p-type substrate at different annealing temperature. Characterization of
यहाँ तो भाई
CDIC.
थैंक यू स्लाइड आ गई है. यहाँ थैंक यू स्लाइड दिख रही है. आप कुछ बोल रहे हैं?
सर कंक्लूजन है ये.
कंक्लूजन नहीं भी आया था और लास्ट स्लाइड भी आ गई थैंक यू वाली. जो बोल रहे हैं उसी की स्लाइड रखिए ऑन, है ना.
ठीक.
और जल्दी से समाप्त करिए, आपका टाइम हो रहा है.
AFM data show the CDIC thin film layer in a homogeneous and distribution of grain is uniformly. AFM image also that show the crystalline size of CDIC thin film increase with increased annealing temperature. Crystalline size calculated from SRD data increase with the increase of annealing temperature, which is the also matched with AFM data due to the increased annealing temperature. Other structural parameters like lattice spacing, lattice constant, dislocation of micro stain, also attractive band gap of CDIC thin film. Study of ultravisible spectroscopy. Other optical parameters also influence due to the increase of annealing temperature. According to all surface morphological, statistical and optical data, it clear that very useful technique of deposit highly efficient thin film. Thank you. Thank you, sir.
Okay, okay, I can hear you. Thank you. Any questions
These are
from audience? Any questions from audience?
these are
आप मुझे बताएंगे कि आपका ऑब्जेक्ट क्या है, काम का क्या काम करना चाह रहे हैं, किस मटेरियल पे, मतलब आपके अचीवमेंट्स क्या रहेंगे ये एप्लीकेशन वाइज।
सर सीडी ऐसी थिन फिल्म है, पी टाइप सिलिकॉन सब्सट्रेट है, इस पर थिन फिल्म बनाई है।
कितनी थिन है, व्हाट इज द थिकनेस? इसमें सोलर सेल कैसे?
100 नैनोमीटर।
80-100
नैनोमीटर
1000, 80-100 means 8000
नैनोमीटर 100 नैनोमीटर।
ओके। और हाउ आर यू प्रिपेयर्ड प्लानिंग टू प्रिपेयर अ सेल? सेल कैसे बनाएंगे और कौन सी लेयर्स रहेंगी, बताइए जरा।
सर रिपीट द क्वेश्चन।
How are you going to fabricate the cell or the solar cell? How are you going to fabricate the photovoltaic cell?
पी टाइप और टाइप को जोड़कर।
किस किस को?
पी टाइप को
और
एन टाइप को।
कौन सा पी है और कौन सा एन है, बताएंगे जरा।
सर जिसमें इलेक्ट्रॉन ज्यादा होता है पी टाइप, जिसमें कम होता है एन टाइप।
क्या सच में ऐसा है?
हाँ नहीं
चलिए ठीक है।
कैसे जोड़ सर का क्वेश्चन है, आपने सुना, मैंने आपका प्रेजेंटेशन भी देखा, तो आप अगली बार थोड़ा अच्छे से तैयार करके आएंगे तो बहुत अच्छा लगेगा आपको, सब बहुत चीजें सीखने को
हाँ,
मिलेंगी।
मतलब ये इट इज ऑल अबाउट सेल्फ एंजॉयमेंट, इट इज ऑल अबाउट सेल्फ एंजॉयमेंट, सेल्फ सेटिस्फैक्शन। Okay, now you can stop presenting. Thank you. Okay. So next in the queue is a group of Prosenji Sarkar, Nisa Pawan Kumar and Ram S. Katiyar. And they are going to discuss about study of optoelectronic properties of thermal evaporated tin monoselenide thin films. So who is going to present from this group? Is there anybody belonging to this group? I repeat the names: Prosenjit Sarkar, Nisa Pawan Kumar, Ram S. Katiyar. Title is study the optoelectronics property of thermal evaporated tin monoselenide thin films. Okay, they seem to be absent, I suppose. So moving on, next presenter are TM Parasumkar, AN Yerpude and SJ Dhoble. Who is going to represent this group? Title of the talk is Photoluminescence in SM+3 CAMG B205 inorganic phosphors for environment friendly solid state lighting applications. TM Parsuramkar, AN Yerpude, SJ Dhoble. Okay, they also seem to be absent. Next group is KM Sujata, Puspanjali Patel, Prerna Gupta and RG Solanki. On the title, the first principle study electronic and optoelectric properties of bismuth sulfide.
Yes, sir.
Okay. Ms. Sujata is there. Are you ready, Sujata ji?
Yes, sir. Yes, sir.
Please. As I can see from the list of joinees, Professor D.M. Parsuramkar is present here. Sir, can you hear me?
Yes, yes, sir.
What about your scholar?
Hello.
Hello. Can
Yeah,
you hear
yeah.
me?
Yes, I can hear you.
Yeah. I am
Hello.
ready with my presentation, sir.
So you can immediately start, or you can present after Sujata.
No problem, sir. After Sujata, I can present.
No problem. Okay. So after Sujata, you be ready. Sujata,
Yes.
you please start. Thank you.
Yes, sir. Sir, I'm visible.
No. Neither you nor your presentation is visible. Neither you nor your presentation.
Okay, sir. Okay.
Yes, your presentation is visible now. Please start. Sujata.
Yes, sir. Yes, sir. Good afternoon to all of you. Myself, Kim Sujata from Dr. Hari Singh Gaur University. In the Department of Physics, I am working under the Dr. Rekha Shubhamurthy. These are my contents. Importance of bismuth sulfide solution. My topic is the first principle, a study of electronic and optical properties of bismuth sulfide. These are some contents. Importance of bismuth sulfide, thermoelectric effect, computational details, result and discussion, optical result, and then summary. Importance of bismuth sulfide. Bismuth sulfide is an N-type fourth, fifth group semiconductor material that belong to the cousinide of the type Bi2E3, where B is a bismuth and E is a sulfur, selenium, and telluride. Bismuth sulfide is a non-toxic semiconductor, and its banded energy ranges from 1.3 to 1.7 electron volt. Bismuth sulfides belong to a second generation topological insulator, as they have insulating bulk and gap and conducting state on their surface by the presence of a strong spin orbit interaction, which involve the orbital character of conduction and valence band. Bismuth material is functional compound and very attractive material for a wide range of applications such as photovoltaic, thermoelectric, photocatalyte activity, micro and optoelectronic devices, photo electrochemical and infrared detector, but my am for a thermoelectric application. These materials show as a thermoelectric materials. So we talk about thermoelectric effect. In 1821, Thomas Johnson Seebeck discovered that the temperature gradient in a conductor brings an electric potential voltage It is properly known as the Seebeck effect or thermoelectric effect. A temperature difference causes diffusion of charges from the hot side of the cold side of a conductor. My material bismuth sulfide. This type of material bismuth and sulfur. This is the computational details. Here I use DFT based computational tool SISTA and non-Carmody pseudo-potential based on exchange and correlation functional and double zeta polarized Bayes set. And also use local density approximation method is preferred, and Rowland-Martin pseudo-potential is used. Structural detail of bismuth sulfide are taken from experimental result. After structural optimization, the cutoff energy is 250 electron volt are used, and K 0.6 into 6 into 6, and lattice parameter is for A is 11.314 angstrom, and B 3.980 angstrom, and C equal 11.014 angstrom. And because structure of this material is orthorhombic, the electronic and optical properties obtained by SISTA result are presented here. Result in this discussion, structural result. Here my optimization lattice parameter is this, and in previous literature are reported this and this. This is the structure of bismuth sulfide for 5 atoms, because here I have calculated for 5 atom calculation. This is so the band gap, band structure, and density of state. The band structure calculation within LDA were plotted with Fermi level at 0 electron volt energy scale in band gap for each bands. So here our material show the indirect band gap, and the value of band gap is 1.01 electron volt. And this is compatible with other result reported in articles. This is the DOS and PDOS, means density of state and partial density of state. And here see that the bismuth 6p are more dominant compared to sulfur 3p orbital. This is optical results, real and imaginary part of dielectric function of bismuth sulfide in X direction and in Z direction. Now the dielectric function of material is examined in order to evaluate its optical properties and real imaginary element of the complex function known as the dielectric makeup in two components, real and imaginary part. In in X direction, the value of real part is 2.64, but in Z direction we see that the value of real part is 2.78, and this range is 0 to 5, approximate 5 electron volt, and in the same in the Z direction. Visual conclusion: the structural, electronic, and optical properties of bismuth sulfide have been investigated using the first principle method using CA scheme of LDA method based on DFT computation. The structural properties show the calculated lattice constant and the bulk modulus are in good agreement with the reported value. The DOS plot show that in the bismuth sulfide, the sulfur s orbital and bismuth p orbital interaction are dominant near the Fermi level. The p-DOS results are in good comparison with both theoretical and experimental data of previous study. Bismuth sulfide is a semiconductor with an indirect band gap of 1.01 electron volt. Optical property reveals that the static dielectric function of this material is 2.64 and 2.78 in the x and z direction respectively. The results show that bismuth sulfide have an anisotropic dielectric constant suitable for optoelectronic devices application below 6 electron volt. These are references. Thank you.
Thank you, Sujata. Any questions from audience side? So I have two questions, Sujata, for you. First question
Yes,
is that what is the accuracy of your results with theoretical calculation and they are supported by experimental data? Because in your in one of the slides adjacent to figure 2, you have mentioned that indirect, direct. Please go to that slide. Yeah, this one. So what is the meaning of writing here in the experimental? Then in the last one you have written some blur in like direct. Okay. Then you have written in second you have written indirect. Then theory, indirect. Then theory. What is that?
सर एक्चुअल में मैंने जो लेटिस पैरामीटर लिया था वो एक्सपेरिमेंटल डेटा से लिया था जो रिपोर्टेड है पहले, ठीक है। उसके बाद हम क्या करते हैं, इसको ऑप्टिमाइज करते हैं। तो जब हम इसको ऑप्टिमाइज करते हैं विथ सिस्टा सॉफ्टवेयर से, तो जो लेटेस्ट पैरामीटर है वो मॉडिफाई हो जाता है। तो ड्यू टू मॉडिफिकेशन जो हमारा बैंड गैप होता है वो चेंज हो जाता है। तो जो यस सर, क्योंकि लेटेस्ट पैरामीटर जब हमारा चेंज होगा तो ये अभी याद नहीं आ रहा है सर, ये रिलेट करता है जो बैंड गैप से होता है। अगर ये मॉडिफिकेशन होगा तो हमारा जो बैंड गैप होता है उसमें भी मॉडिफिकेशन होता है। तो एक्सपेरिमेंटल
इनडायरेक्ट बैंड गैप
सर इनडायरेक्ट है, मैंने शो किया ना इनडायरेक्ट बैंड गैप, क्योंकि जो
मतलब
हमारा ये
बैंड गैप मटेरियल का
सर
व्हाट डू यू मीन बाय इनडायरेक्ट बैंड गैप मटेरियल्स?
सर इनडायरेक्ट बैंड गैप का मतलब ये होता है कि जो मोमेंटम होता है, जैसे ये हमारा ये मैच नहीं करता, जैसे ये गामा पॉइंट है तो जो ये हमारा मैक्सिमम ये शो करता है और ये लोअर शो करता है, जैसे मींस मोमेंटम हमारा जो के होता है दिस इज द के पॉइंट इन द ब्रिलॉन्ग जोन, तो ये सेम नहीं होता है। बट इन द डायरेक्ट बैंड गैप जो हमारा ये कंडक्शन एंड बैलेंस बैंड का जो ये मोमेंटम है, जैसे वेव वेक्टर हमने शो किया है, तो ये सेम हो जाता है, ये मैच कर जाता है। तो ये हमारा होता है डायरेक्ट बैंड गैप। तो यहाँ पे ये यहाँ पे जो हमारा शो हो रहा है ये मोमेंटम हमारा सेम नहीं है, इसलिए हम ये कहते हैं कि ये इनडायरेक्ट बैंड गैप है।
चलिए ठीक है, आगे बढ़िए, थोड़ा आगे स्लाइड्स में जाइए, चेंज द स्लाइड्स प्लीज। आगे ये जो आपका ये इंसर्ट में जो लिखा है वो मेरे समझ में नहीं आया, क्या लिखा? आर ई ऊपर जो इंसर्ट में लिखा ना
रियल पार्ट, ये जो हमारा ये
रियल एंड इमेजिनरी लिखा।
हाँ रियल एंड।
चलिए आगे बढ़िए।
सर ये कंक्लूजन
अच्छा आपका ठीक है। Any participants willing to ask any question?
Thank you.
Thank you, Sujata. Thank you so much.
Okay, thank you, sir.
You can stop presenting now. So the title of next presentation is Photoluminescence in Samarium 3 plus CaMgB2O5 inorganic phosphors for environment friendly solid state lighting applications. And Professor DM Parsuramkar is here to share his
Yes, sir.
work. Please.
Yes, sir. It's the presentation visible.
Yes, coming up.
Is the presentation visible, sir?
Yes, yes, yes.
Yeah. Myself, DM Parsuramkar from NS College Brahmapuri East, Chandrapur. My co-workers are Dr. A.N. Yerpude from my same college and Dr. H.J. Dhoble from Department of Physics, RTM, Nagpur University, Nagpur. My today's presentation is on photoluminescence in SM3 plus activated CaMgB2O5 phosphors for environment-friendly solid-state lighting applications. The content of my presentation is introduction, synthesis method, characterization, results, and finally the conclusion. First of all, we have to introduce what is exactly the luminescence is, because my today's topic is on photoluminescence. Therefore, first of all, it is our aim to know what is exactly the luminescence is. In fact, this luminescence phenomena is a cold emission of light. It is not a hot emission. It is the cold emission of light, or in other words, we can say it is a different form incandescent, which is a hot body radiation. This luminescence process is involved mostly in 3 steps. First of all, energy absorbed from the external source causing electronic excitation. Then this energy will be stored with absorption, and then there is a emission of photon depending on the storage time. This 3 step process is called as luminescence. There are certain different type of luminescence are there: photoluminescence, cathodoluminescence, radioluminescence, electroluminescence, chemoluminescence, bioluminescence, triboluminescence, thermoluminescence. Actually, these luminescence are classified by using what is the external energy source. In my research work, I mostly use the photoluminescence, where we have got the luminescence from photon or exciting with some light source. That is photoluminescence. Why I can choose this particular research field? Because there are some changing scenario in the lamps propagation, or in the history. First of all, the people are using the candle in year 1800. Then after that, in 19th century, people are believing to be use a bulb. Then the technology revolution are there. In 2000, CFLs are come, but these CFLs have some mercury evaporation problem, and due to this mercury evaporation, they are not environment friendly. Therefore, nowadays people are working on LED, which are mercury free environment and produce a good environmental impact on the lighting technology. Therefore, people are using this LED technology nowadays. Therefore, my work is on this LED technology. For this purpose, or by preparing my sample of CaMgB2O5, which is samarium doped phosphor, I use the combustion synthesis. Initially, I take the ingredient as calcium nitrate, magnesium nitrate, boric acid, urea as a fuel, and samarium oxide. Then I take all the ingredients or mix according to their stoichiometric ratio in the azet mortar, and some pasty solution was formed. Then this solution is transferred to silica crucible and kept it in a muffle furnace, which is preheated at constant temperature of 550 degrees Celsius. After a quick time, a flame with a foamy powder was formed, and then that powder was collected and analyzed by the photoluminescence measurement. First of all, we take the characterization for the prepared sample CMG B2O5 SM3 plus phosphor as a photoluminescence study. And for the photoluminescence study, we have taken the photoluminescence study by RF501 PC spectrophotometer, which is available in Department of Physics, RTM, Nagpur University, Nagpur. With this, we are taking the photoluminescence study. Then we have the result and discussion for this particular study. We seen here in the presentation, there is an excitation spectra of CMG B2O5 SM3 plus phosphor, where this excitation spectra we are analyzed here for the samarium concentration of 0.5%, 1% and 1.5% phosphor, and we've seen that the excitation bands at 347 nanometer, 364 nanometer, then another at 378 nanometer, then 405 nanometer and 419 nanometer respectively. And these corresponding excitation bands are excitation lines are corresponding to the electronic transition of first one 347 nanometer is for 6H52, 4S92 electronic transition. Then 364 nanometer excitation is for 6H52, 4D32 transition. Then third one that is 378 nanometer is for 6H52, 4D12 electronic transition. Then 405 nanometer excitation is observing for 6H52, 4F72 electronic transition, and last one 419, which is for 6H52 to 6P52 electronic transition. Okay, but in this excitation spectra, we merely seen that the PL intensity at 405 nanometer of wavelength is the highest in this particular excitation spectra that is used for the emission analysis. Okay, then the another spectra we got which is emission spectra of CMG B2O5 SM3 plus phosphor by using the excitation at 405 nanometer, which is having the highest peak in the excitation spectra. Therefore, we are choosing that excitation, and by using this excitation, we have to analyze the emission spectra, and the results are shown in the diagram. The strongest peak at 5904 nanometer wavelength is observing there, that contribute the orange color emission or orange wavelength emission transition of SM3 plus ion, which is due to the hypersensitive 4G52 to 6H72 electric dipole transition. Here we are observing the electric dipole transition for that 594 nanometer wavelength, which is in orange color range. Then the another emission spectra, emission peak is observed at 563 nanometer, is mainly from the 4G52 to 6H52 magnetic dipole transition of the prepared phosphor CMG B2O5 SM3 plus phosphor. And we are analyzed here for the concentration of SM3 as a 0.5, 1, 1.5 respectively. And we've seen that for the 1 mole percent, we got the maximum intensity here in the emission spectra. Then we study the concentration quenching for this CMG B2O5 phosphor. Then the concentration quenching suggests that for 1 mole percent of SM3 plus, we got the more intensity or maximum intensity.
Professor Parsuram, please conclude. Okay,
sir, the conclusion is that in our present research work, we are preparing the CMG B2O5 SM3 plus phosphor, which is by combustion method, which is very simple to follow. Then the emission spectra show the characteristic band of SM3 plus ion observed at 563 nanometer and 594 nanometer. The concentration quenching is observed at 1 mole percent, means we have to choose 1 mole percent for the future work. Then the same image is shown here, the irregular surface morphology with microcrystalline structure, and the PL result shows the excitation peak at 405 nanometer, which is useful for the solid state lighting lamp industry. These are the particular possible application of research work which are used for the different LED applications. Thank you very much, sir.
Thank you, sir. Now the session is open for queries.
Yeah.
Any queries from audience side?
Sir, hello.
Yes, yes. Please speak.
Sir, in PL emission spectra, you explained that the peak near about 594 nanometer, which is due to 4G 5/2 to 6S11, 6S7/2 transition belongs to electric dipole, and the peak at 563 nanometer is due to magnetic dipole. Sir, I want to know how can we differentiate this electric dipole transition and magnetic dipole? How can we know that the 594 emission is due to electric dipole and 563 is due to magnetic dipole transition?
Actually, we are just go through the theory. Then, according to the theory, we are not going for that particular wavelength range. Our focus is on transition. What type of transition is this? And if you go the atomic transition, we've seen that for this particular phosphor, that 4G5 to 6S72 transition is related to electrical dipole transition. That is already given in the theory. Therefore,
no,
from
sir,
that
but
theory,
I want to know how this is calculated. Is there any formula so that we can know that this is belongs to electric dipole and this belongs to magnetic dipole?
No, there is no formulation for that. You go to the theory for that. For particular material or any organic, inorganic material, you've seen that according to that particular transition. Some are the forbidden transition, some are the allowed transition. In that category, we have to go through this particular magnetic and electric dipole transition. From that, we get that data. Is it electrical dipole transition or magnetic dipole transition?
Okay, sir.
Okay.
Any other question? Okay. So I have a question. Like, for example, in any of the graphs, sorry, for excitation or emission, though you have mentioned the value of X means the doping concentration, right?
Yeah. Doping
concentration
concentration of
half,
binary.
1.5%.
Yeah.
So for 1.5%, which color you are showing? That blue one, right?
Yeah.
But as you have said that for 1 molar concentration, that I suppose because you have not included X value in the formula. So that's why it is confusing a bit. So how would you say that quenching has occurred at X equal to 1 and then 1.5 value is even lower than that? Is it so?
Yeah. From this concentration quenching, you see that for 1 molar percentage for the 594 and 563 of emission, we got the more intensity for that 1 mole percentage. Therefore, we just concluding that among the three, we have the concentration quenching for 1 mole percent.
But you have not drawn up to 1.5. This is only up to 1.4.
Yeah.
Previous one.
Yeah, last one is 1.5. Last one is 1.5. After 1.4, that is 1.5. Okay.
Go for the last slide that we could not see, in which you are saying, this one. So, previous. Yeah. Same images. Okay. So, for what concentration these images are there and how they are different from each other, two images?
Actually, we are having the morphology for the same, and we are focusing here in the different angle. Then for particular this, we got the 5 micrometer, that micrometer size for the grain size of that particle, and here we got the 10 micrometer of in the range of 10 micrometer. Means our prepared phosphor is in the micrometer range. Their particle size of ranging from 5 micrometer to 10 micrometer range.
So these images are corresponding to same sample, right?
Yeah. This is for
magnification is different.
Yeah, that magnification is different. In first is the 3500 magnification, and in the second 1500 magnification.
Okay. So my last question is, that you have said that the emitted wavelength is around 400 nanometer, as you said?
Yeah. Emission is 563 nanometer.
Okay, 563 up to like
5904.
okay. So 563 means green, yellow and green almost, right?
Yeah.
So how we can be assured that this light where other colors like red and orange are also required, this will be suitable? What is the suitability of this?
For that, we are using the different dopant. Means instead of SM3 plus, we can use U3 plus, DY3 plus. Then we got the different wavelength for that.
Okay, thank you. If there is no other questions, thank you, sir.
Okay.
Okay. So, is there anybody from organizer side? Are we supposed to take a break or we can continue?
No, I can continue. Bhargavi, ma'am?
Yes, sir. Yes,
Okay. So, next group of presenter is Nitika Sah, Namita Brahme, DP Bisen, Yugos Patle, Sukhraj Nureti, Yuvraj Singh Jagat, Durgesh Kumar Devangan. And their presentation is based on the topic spectroscopic analysis of DY3 plus incorporated calcium gallium silicate phosphor. Nitika Sah is there, I think.
Yes, sir.
Nitika, you can start your presentation.
Yes, sir.
First, you be on the camera and then start presenting.
So the slides are visible? Hello?
Yes. Yeah. They are visible. Please start.
Okay, sir. Good evening, everyone. My name is Nikita Shah, and I'm pursuing PhD from School of Studies in Physics and Astrophysics under the supervision of Dr. Namita Brahme. These are the outline of the presented topic which will be discussed. Firstly, as we know that there are two practical way to produce light. First one is incandescence and second one is luminescence. Where luminescence, incandescence is the emission of light resulting from heating any object at high temperature. But the disadvantage of this method to produce light is the majority of radiation is emitted in infrared region, which cannot be seen by human. And this process, a lots of energy is felt in the form of heat. And the second process is to produce light is luminescence, where luminescence is re-emission of light from any solid after absorption of energy from external energy source. And the fireflies, their examples are fireflies and LEDs are the example which consume less energy. In my topic, my studies is based on the spectroscopic analysis of dysprosium doped calcium gallium silicate phosphor. So my research is focused on mainly focused on the photoluminescence properties of the phosphor material. Photoluminescence is the emission of light which emission of light after absorption of photon energy, and this process when electron absorbs the energy and jumps to the higher electronic state, and when this excited electron returns to its ground state and emit energy in the form of light, and this whole process is known as photoluminescence process. The process of photoluminescence can be well understood by the Jablonski diagram. Why silicate based phosphor material? We use silicate based phosphor material because it's so excellent water resistance properties, and it highly chemically and physically stable among other phosphor materials. So we use silicate. So I use the silicate based phosphor material for my studies. These are the synthesis process of the material. I have prepared my sample using solid state reaction method. In this process, in the raw as a raw material, we used calcium carbonate, gallium oxide, silicon dioxide, and dysprosium oxide as a raw material, and all the raw material were weighted according to the stoichiometric ratio, and the material were mixing and grinding through agate, mortar, and pestle for 3 hours, and then material is calcined at 900 degrees centigrade for to remove the gases, and again phosphor is fired at 1350 degrees centigrade to diffuse the for preparation of the required sample. These are the XRD patterns of the prepared material. Through XRD analysis of the phosphor material, we have concluded that the all diffraction peaks of the material is well matched with the JCPDF file. As we can conclude that the prepared phosphor has single phase, and the particle and the crystalline size of the prepared phosphor were calculated by the Debye error formula, where K is the Ceph factor and lambda is the wavelength of the X-ray, and beta is the full width half maxima, and theta is the cos theta is the diffraction position of the material, and the calculated particle size of the phosphor is 42 to 54 nanometer of the all phosphor material ranges from the 42 to 54 nanometer, and the prepared phosphor has a tetragonal crystal structure according to the previous literature. And this is the FTIR spectra, which confirms the presence of hydroxyl group. This is line. This wave number is show the presence of hydroxyl group in the prepared phosphor, and 1900 to 1700 wave number show the presence of carbonate groups in the prepared phosphor. This one, the excitation spectrum of the calcium gallium silicate phosphor doped with dysprosium ion. There are excitation spectra of the Prepared material shows several excitation peaks at 348 nanometer, 386 nanometer, and 451 nanometer, in which 348 nanometer wavelength is used for monitoring the PL emission spectra of the dysprosium doped calcium gallium silicate phosphor, and this won the emission spectrum of the dysprosium doped calcium gallium silicate based phosphor. Emission spectra of the prepared phosphor show two excitation peak, 184 nanometer wavelength, and second one is 575 nanometer. This emission, the 484 nanometer emission peak arises due to transitions of 4F9/2 to 4,6H13/2 transitions of dysprosium ion, and the second one 575 nanometer wavelength emission is occurs due to 4F9/2 to 6H15/2 transitions of dysprosium ion, and the intensity of the 484 nanometer is wavelength is highest. Thus, it is concluded that the dysprosium ion is situated at low symmetry site, and the concentration quenching is occur at 3 mole percent doped dysprosium ion. And this is the CIE diagram of the prepared phosphor, and the CIE coordinate are calculated. X is equals to 0.31 and Y is equals to 3.2 for 3 mole percent doped dysprosium doped calcium gallium silicate phosphor, and the corresponding correlated color temperature is 6735 Kelvin, and the coordinates are situated at the near white light, and thus we concluded that the prepared phosphor successfully synthesized by solid state reaction method, and the diffraction peak of the as synthesized phosphor is well matched with the JCPDS, and no impurity phases will be detected. And the FTIR spectra analysis, it confirmed the presence of hydroxyl group and carbonate in the prepared phosphor, and dysprosium doped calcium gallium silicate phosphor emit white light, which was confirmed by the CIE coordinate. Thus, the prepared phosphor can be used as UV excited white LEDs. Thank you.
Thank you, Nitika. Any questions from participants? There seems to be no question. So you have stopped presenting because I lost connection in between. So you please present it once so I can have a review of the slides. Okay, no problem. If there is any problem, we can. Nitika, can you hear me?
Yes, sir.
Is there any problem in presenting?
Sir, I don't know how to exit.
Okay, no problem. So actually, as I saw, the emission spectra they are having so much of noises. Secondly, there were so many other humps or shoulder peaks also. So, but you did not discuss anything about that. Secondary peaks were also there, and the peaks are not very sharp, what I could see. So why like flatter peaks? What does it mean? And how did you ascertain the morphology? Because you have not shown, I suppose, like you have shown, because I was absent here for 2 or 3 minutes. So did you show some morphological studies, results of some morphological studies?
सर इन सर आप XRD स्पेक्ट्रा की बात कर रहे हैं?
XRD is different, SAM or HRTM or you can say FESAM.
सर वो कैरेक्टराइजेशन मैंने सर अभी कराया नहीं है. एक्चुअली मैंने अभी सैंपल बनाया तो जस्ट उसमें जो मैक्सिमम इंटेंसिटीज जो पिक थी मैंने उन्हीं को बस वेल मैच किया, तो उसके अकॉर्डिंग मैंने ये डिस्क्राइब किया कि फॉस्फर बन चुका है करके सर.
अच्छा. So what is the nature of the material prepared? Like कौन सा सिस्टम बता रहा है? क्यूबिक है, हेक्सागोनल है, क्या है?
सर टेट्रागोनल क्रिस्टल स्ट्रक्चर है सर.
अच्छा, tetragonal structure.
यस सर.
So this is in line of your expectations or this is something different? मतलब आप जैसे चाह रही थी वैसे ही है कि कुछ?
सर ऑलमोस्ट तो सर 80% सर स्पेक्ट्रा मैच कर रहा है. बाकी सर मे भी हो सकता है कि हम लोगों ने जो सैंपल यूज किया मे भी प्योरिटी के कारण हो सकता है सर. जो रॉ मटेरियल
You have to ensure purity. See, never say that due to impurity. You should say that if you say that impurity was there, then what is the object of doing so much of hard work, right? And for what did you, with what purpose did you perform this FTIR spectral studies?
so presence of groups.
So how this study will help you in achieving your goal?
सर बेसिकली मैंने FTIR इस वजह से कराया था कि इज देयर चेंज इन द जो मेरा मटेरियल है वो मॉइस्चर रिएक्टेंट है या नहीं सर.
अच्छा, चलिए ठीक है. थैंक यू नीतिका.
Yes,
If there is any question or query from audience side, if there isn't any, then we can go for the next speaker. Thank you, Nitika. Thank you. So the next group of speaker is Priyanka Roy, Sanjay Tiwari, and Ayush Khare. So Priyanka Roy, are you there? She is not here. Okay. So now we have come to the end of this session with the last talk by B.R. Verma. So B.R. Verma sir is here. Verma sir, are you here? Okay. So this was session 4 of this event, where a total of 6 presentations were made. Okay, and the presentations that were made were based on, first presentation was by Piyush Jha on the importance of mechaniluminescence, and he used like he explained how this mechaniluminescence can be used for visualizing the cracks in materials or buildings. Am I audible?
Yes, sir.
Yes, sir.
Okay. Second talk was by Chiranjeev Lal, who threw some light on the synthesis of CDT thin films for photovoltaic applications. Next in the line was Professor Parsuramkar, who shared his results on calcium, magnesium, boron iodide, oxide that was doped with samarium, and his work was in the direction of achieving applications or getting some good applications for solid state lighting. T.M. Sajata presented her work based on first principle study electronic and optical properties of bismuth sulfide. Next, Nitika Sa earlier, who was the last presenter who described the results. Her results where she doped calcium gallium silicate with dysprosium 3+ ions. So this was session 4 in which a total of these presentations were made. So now I would like to hand over the proceeding to the organizers. Bhargavi, are you there?
Yes, sir. Yes, sir.
Okay.
So this is this fourth, and on behalf of organizing committee and on my personal behalf, I would like to thank Dr. Ayush Khare for patiently listening all the oral presentations and as well as judging too. I also thank Dr. Vinod Dubey sir. He is one of the judge, and thank you so much, sir. And my thanks are to Dr. MP Sharma. He is the resource person of this technical session. Thank you so much, sir.
Thank you, ma'am. Thank you, ma'am.
Okay, sir. Thank you so much. My thanks to all the participants, the oral presenters who presented their research work in this seminar. So thank you once again. And on behalf of organizing committee, there is a small announcement. We will start the valedictory session very soon. Respected principal sir is about to join. So please stay with us. We will be starting the valedictory soon.
And the names of best participants for oral presentation will be announced. So be connected, and I would request all the participants to join this valedictory. And I will also would love to listen from the participants about their feedback for this seminar, because this was quite a new experience for all of us. We collaborated, we networked, and we formed a very energetic organizing committee. And because of that only, we could reach to all parts of India and to the experts of various state-of-art institutes and the participants from Kashmir to Andhra and Tripura to Orissa. So we covered almost all parts of India, and which gives the true national character to this seminar. So it was actually an experiment for all of us, and I'm quite satisfied with the outcomes. So we will soon start, and I would request Bhuneshwar Verma sir to kindly connect PC Chaubey sir, who is going to be the guest of honor for our valedictory function, to connect him so that we can start. And I would request Ayush Khare sir to be with us and also give his feedback as expert about this kind. Thank you. MP Sharma sir is also here, so kindly stay with us, and it will be very nice if we have our experts and who will comment and actually give their feedback, honest feedback, then what can be done for research. Because we could see that some of the researchers were very proficient in presenting their work, but some of them need some kind of guidance. And as I was seeing that Ayush Khare sir was very patiently guiding one of the presenter to be prepared for the next time. And so this kind of activities are very important. And in NIT I have seen, because I've been co-supervisor of a few students, so I saw that they ask students to present their work frequently, quite frequently they have to present their work, and that gave them a lot of confidence. So if we don't have such kind of a ruling for the research scholars in who are pursuing research in college or other university, so this kind of platform can be provided to the researchers so that they can gain confidence, and they are also mentored by the chairpersons and the experts on presentation. And like Tanmay Mahapanda sir was there, and Bada Panda sir was there, and he and Ayush Khare sir, they all gave their inputs to the students for the betterment of the research. So it was really quite satisfying experience for me also. And Bhuneshwar Verma sir, kindly tell us when you connect us.
Khare sir, please send the Excel sheet to me. Khare sir, please. You are not audible, sir. Muted.
Ayush Khare sir, Can you hear me? Khare sir? The judgment sheet is to be provided to
Sir, please, you are muted, sir. खरे
सर ने
सर
नहीं दिया तो सर कनेक्ट करना सर को, प्रिंसिपल सर को, अब हमारा शुरू होने वाला है।
नहीं तो खरे सर का आएगा तभी तो अपन को नहीं अनाउंस करेगा।
ओके
हम रुक जाने को बोलेंगे।
अच्छा खरे सर उनको मैसेज करो खरे सर को कि
नहीं मैं मैडम को किया।
So you got the sheet? अच्छा call. Two minutes, we will start the valedictory. So please be with us. देखो तो भेज के नहीं भेजा।
Bhargavi, did you receive it?
अच्छा भार्गवी मैम को भेजा है आपने?
Yeah, madam. Yes.
ओके भार्गवी
सर मेल किए हैं क्या?
हाँ मेल किया मैंने।
हाँ सर एक मिनट में चेक कर ले रही हूँ। हाँ यस सर यस सर।
ओके सर, हो गया, थैंक यू।
Good evening to all. We have prepared the results, and now we will start the we can start the valedictory function. Bhargavi ma'am, please be ready. Bhuneshwar sir will connect principal sir of Science College, Dr. P.C. Chaubey sir, in a short while. I am ready with the report.
Madam Principal sir, Chaubey sir.
Yes, Mr. Verma sir will connect him in short while. He's just going to his room.
Okay, okay.
The day was really challenging for us because in Science College there was no electricity for a long period of time, and even now the voltage is very low. So we were fighting with this power problem. But anyhow, I'm happy that we come to the concluding session.
हाँ चालू हो रहा है मैडम करेंगे
Okay, Bhargavi, please start.
Okay.
मैडम सर ज्वाइन कर रहे हैं
Good evening to one and all present here. Once again, I welcome you all to the last section, that is the valedictory function of this 2 days national seminar on advanced materials and characterizations 2022. As we know, this event was jointly organized by the three colleges. One is the lead college of our district, that is Government Nagarjun PG College of Science, Raipur, and the two sister colleges like ours, that is Government Pandit Shyamacharan Shukla College, Dharsiva, and Government Rajiv Lochan PG College, Rajim. In this joint venture, we have many resource persons and participants throughout the map, and in this valedictory session, First of all, I would like to invite the convener of this seminar, Professor Anjali Audhia, to present the report of this event as well as the results, to announce the results too. Madam, please.
Thank you, Bhargavi ma'am. And so here's the report. Good evening to all, respected Principal Sir, Ayush Khare Sir and MP Sharma Sir, who are here to grace the valedictory function of this two-day national seminar. Actually, we all are emerging or entering in a new growth phase in our colleges and institutions with new education policy and with many new concepts in post-corona era, like virtual classes, virtual seminars like this one, and a lot of collaboration due to which this kind of seminar organized. And I thank you all from the bottom of my heart for making it a truly national character and a truly memorable event. And I request you all to give your honest feedback so that we can organize these kind of seminars in future also, and kindly suggest what kind of topics are to be covered and what kind of experts you want with you. So with this, I start reading the report of the two-day seminar covering all the events. The inaugural session was graced by principals of the three colleges who jointly organized the session, Dr. P.C. Chaube sir, Dr. Shabnam and Dr. Sonita Satsang, which was followed by the release of books of abstract containing around 50 abstracts from researchers from around 9 to 10 states all over India. The day one, that is 26th August 2022, technical program and technical session 1 began with keynote speech by Professor S. Panigrahi, National Institute of Technology, Rourkela. His topic was Pillars of Material Word Synthesis and Characterization, which gave an overview on the synthesis and characterization techniques of advanced materials. The first invited talk of technical session 1 was delivered by Dr. Manoranjan Kar from IIT Patna on tuning of magnetic properties in ferrite-based magnetic composites as advanced material for modern technological application. His lecture was full of fundamental information and techniques to study magnetism in materials, followed by lively interaction and question-answer session. Technical session 1 was chaired by Professor Avnish Upadhyay from Government College of Engineering, Bilaspur. Vote of thanks was proposed by Govardhan Yadu, the organizing secretary of this seminar, and the session was anchored by Dr. G. Nag Bhargavi, the organizing secretary. The technical session of day 1 was chaired by Professor M.L. Verma from Sri Shankara College of Engineering and Technology, Bhilai. The session began with invited talk delivered by Dr. Alka Garg from Gargi College, Delhi University. She presented her work on polymer composites of metal iodide for direct X-ray detection for optoelectronic and photovoltaics application. She intricately described the characteristics of materials to be chosen for this technique, synthesis procedure, and also described the removal of the high signal to noise ratio during observation. Technical session 2 was followed by 14 oral talks scheduled for the session, and Dr. Vinod Jena of Science College, Raipur was there for judgment of best participation. Day 2, that is 27th August 22, began with technical session 3. This session was chaired by Dr. Tanmay Badapanda, C.V. Raman Global University, Orissa. His interaction and inputs made the session really lively. The invited talk for this session was delivered by Dr. Ila Sinha from Birla Institute of Technology, Misra, Ranchi, on recent development of SOFC, an effective energy conversion device. She actually discussed the features of efficient fuel cell in detail and about the recent advances in that field. Total 10 oral talks were scheduled in this session, which were completed successfully with nice presentations from the participants. Dr. Vinod Jena was given the responsibility for judgment of best presentation in this session too. Day 2, technical session 4 was chaired by Dr. Ayush Khare, Department of Physics, NIT Raipur. He is still with us, and the invited talk on this session had the title Ferrites, Synthesis, Characterization and Applications. This was presented by Dr. M.P. Sharma from Guru Ghasidas Central University. He has been working on magnetic properties of perovskites and transition metals and has published more than 35 research papers in the field, and his session was really very informative. Dr. Vinod Dubey was assigned for judging best presentation, and 14 oral presentations were scheduled for this session. Then there was a parallel technical session for oral presentation in order to accommodate overwhelming number of participants for oral talks, which was chaired by Dr. Bhuneshwar Verma from Government College, Science College, Raipur. Dr. Sameer Thakur was invited for judgment. Now we are heading towards the valedictory function, and Dr. P.C. Chaubey is here for as the chair of this session, and I would like to announce the results for the best presentation of the two-day seminar. So here we go. There are in all 5 best presentations from 4 technical sessions, and the fifth prize or fifth place is given to Devendra Devangan, who is Assistant Professor of Chemistry from Rajim College. Then 4th position was bagged by Shoaib Abbas from Kashmir Central University. 3rd position won by Jayashree Mohapatra, NIT Raipur.
Thank you, ma'am.
2nd position, Piyush Jha from NIT Raipur. And the 1st position goes to Tripti Richaria. She is a student of our college, Science College, and actually did her PhD from university under the guidance of Namita Brahme ma'am and Bisen sir. And she is working in Kalinga University right now. So these are the participants. Dr. Nag Bhargavi compared the session, and Dr. Bhuneshwar Verma and Dr. Rashmi Priya Topo prepared the results. So I would like to personally thank all the speakers, judges, organizing committee members, and most of all the research scholars who have joined from all over India. I believe we can benefit immediately from the fundamentals of research shared in the seminar. The enthusiasm of the young researchers and students participating in the seminar is really contagious. Thank you again for your participation. And with this, I conclude the report of today's seminar. Thank you so much.
Thank you, madam. Congratulations to the participants. Now I request Principal Sir, Dr. P.C. Chaubey Sir, to address this session and bless us. Sir, please.
Good evening, everyone. Dear participants, seminar was an effort to provide a platform for all stakeholders in the field of research and education, which includes policy makers, academicians, researchers, and for the students pursuing science in any stream in their post-graduation. I thank all the subject experts who delivered lectures in this seminar. I extend my sincere thanks to the invited speakers, Professor S. Panigrahi, Dr. Manoranjan Kar, Dr. Alka Garg, Dr. Raut, and Dr. M.P. Misra. We are grateful to the time and effort by you to share your thoughts and experiences with the students, researchers, and academicians. The organizing committee has done a commendable job for organizing this seminar at minimum cost and resources, showing the power of unity, where 3 colleges joined together with their faculty members, research supervisors, and research scholars to make this event a success. I congratulate Dr. Anjali Odhia, convener of the seminar, Dr. B.G. Sharma, and Dr. Bhubaneswar Verma, co-convener, and Dr. N. Bhargavi, and Dr. Govardhan Yadu, the organizing secretary of the seminar, along with the head of the institutions of Government College Dharsiva and Government College Rajim, faculty members and students for making this event a success. It was wonderful to know that more than 50 research papers were received and were presented during this seminar. I congratulate the researchers who are declared amongst the best 3 presentations. I appreciate the overwhelming response to this seminar has received from researchers and academicians from all over India and from our own state of Chhattisgarh. I believe that this seminar will generate new ideas, innovations, and strategies to address the challenges which researchers face during their journey. Thanks to all.
Thank you. Thank you, sir.
Thank you so much, sir. Now, I request Dr. Ayush Khare from NIT Raipur to speak few words on this seminar, and your positive feedback will definitely help us to improve for the next event, sir. Please.
Thank you, Bhargavi. There is a well saying that when going gets tough, tough gets going. So this seems to be a perfect example that after a academic recession of 2.5 years, all the people have really started working seriously and sincerely, so that what we could not achieve in last 2 or 3 years, or what we missed, can be compensated. So this was an example. Really, it was nice that not only say a bigger institute or institute of importance is needed to be doing something good, but 2 or 3 good institute or say colleges can come together and produce good things. The good thing is that, like, if we keep on continuing adopting this online version, then it is possible to get people around all people from across the country associated with us. So that is a good thing. Otherwise, if this is in offline version only, as I could see in last couple of days, where Ravi Shankar University organized an international conference, but since being it's purely offline, people could not travel for longer distances. So in future, if this is of both types, like hybrid type, then also you can attract people from Chhattisgarh or nearby places, and you can attract people from remote places through online version also. So but it was good. But participant, as always, I like, as a good teacher or as a good say faculty member, it is our duty to keep on promoting the students and just letting them know that what is needed, what is the demand of time. Because just by having certain results, just by presenting them, narrating them, or even speaking them is not enough in these days. Because when you get a PhD, or you get a recognition, then there are certain I should say expectations of society, of the institute, of the country, that you should be a good speaker, good scholar. So in that direction, whatever is required, we need to do. And whenever we are going to present something somewhere, it is our duty to be fully equipped. Like, either you be this side or you be other side. Like, you should be completely equipped so that you can defend your work. Slides should not be both too much, like 20 slides or 30 slides. You can have 5 or 6 slides and then discuss them thoroughly. So that will sharpen your knowledge, and you can be able to impress others. So this is, otherwise it was a good event. Thank you so much.
Thank you, sir. And now we can quickly take few feedback from few participants.
MP Sharma sir is also there.
Yes, yes, madam. Sorry. MP Sharma. Now I request MP Sharma sir from Guru Ghasidas Central University. He was one of the resource person. Sir, please share your views on this seminar.
Already Khare sir shared all the things. So I am giving again a congratulations to you, both the teams. Both means 3 of the teams, okay. And now you can continue this kind of the conferences to be held on. So, okay, the rest is fine. Okay, ma'am.
Yes, we need cooperation from the subject experts like you and Ayush Khare sir.
Yes, we already supported you, ma'am. No more. Anyway, yeah. Thank you.
Thank you so much, sir.
As I can see, you all 3 partners have been associated with NIT from past. Bhargavi has done PhD from NIT. Madam is a supervisor from NIT. Bhubaneswar Verma sir, we have been discussing so many good things together like that. Govardhan Edu, the third partner, is also quite associated with me. So if this keep on going, then definitely results will be good.
Yes, yes. So it is
Thank you,
always
sir.
an honor to be involved IT along with all other institutions. So we need your support for that also. Thank you, sir.
Yes, madam. We already associate with the Bhargavi ma'am. Last time
Yes.
yeah.
Yes, sir.
Right.
Yes, sir. Last time in our college, when there was a seminar in 2019, that time
Yeah,
MP
yeah.
Sharma sir and so many other respected professors from Central University has joined, and they gave status to the seminar.
Yes, yes.
I must appreciate this. Thank you so much, sir.
Thank you, thank you.
It was 18 January.
Yes, sir.
18th
2009.
January.
Yes,
18 nahi, sir. 19. It was 19
January.
Ayush is there. Yeah, January year.
January.
Date was 18 January, I suppose. 18 January
Date
2019.
was 18 January 2019. Yes, sir. Okay, thank you. So may I request some of the participants to please give feedback on this seminar? I can see Soeb from Central University of Kashmir. Soeb, are you listening me?
Yes, ma'am. Yes, ma'am.
Yes, please.
Thank you, ma'am. Thank you for giving me this opportunity. And thank you very much for organizing this fascinating event. It was quite useful and a nice experience. It generated a lot of ideas for expanding our research and collaborating with others. From the day first, everything was well managed. And I'm thankful to the organizing committee as well, especially you, Bhargavi ma'am. You informed us about all the events, about all the technical sessions well in time. It was quite a nice experience. It would be a great pleasure to be the part of these such more events, ma'am. Thank you so much.
Thank you, Shoaib. Any other participant want to give feedback on this seminar?
I would like Hirvani sir to share the feedback form also, so that.
Yes, madam. It is shared. It is shared.
Okay.
So if nobody else is there to speak on feedback, so I think I should move. Now I invite Dr. B.R. Verma from Government PG College of Science for vote of thanks. He is the co-convener of this seminar. Verma sir, please.
Okay, madam. Thank you, Bhargavi madam. Good afternoon to all. I feel honored and privileged to get opportunity to propose a vote of thanks on this special occasion. Firstly, I would like to thank all the invited speakers, Professor S. Panigrihi, Dr. Alka Garg, Dr. Ila Sinha, Dr. Manoranjan Kar, and Dr. MP Sharma. I, B.R. Verma, on behalf of organizing committee, convey deep records and hearty thanks to our technical session chairperson, Dr. Avnish Upadhyay, Dr. M.L. Verma, Dr. Ayush Khare, and Dr. Tanmay Badpanda. My sincere thanks to Principal Sir, Dr. P.C. Chaube, Dr. S. Siddiqui, Dr. S. Sasangi, ma'am, for his help and support at various stages. I am also thankful to our judges, Dr. Vinod Dubey, Dr. S. Thakur, and Dr. Vinod Jena for his gracious presence. I would like to thank our beloved head of the department and convener of this event, Dr. Anjali Awadhya madam, for his constant help and guidance that radiated a source of energy within us. Lastly, I would also like to thank Dr. B.G. Sharma, co-convener of this organizing committee, Dr. Yadu sir, and all organizing committee members, faculty members, and students and research scholars for making this event successful. Thank you so much.
Thank you, Verma sir. So we are at the end again of this session 2. So finally, we have ended this 2 days national seminar on advanced materials and characterizations 2022. And I hope we'll soon meet again with new ideas, with new concept, and again with another national or international conference maybe. Thank you one and all for joining us. And we met nice people, good resource persons, and all the sessions were very informative, very effective. And I hope not only we, all the participants have benefited with the resource persons as well as the presenters also. All the oral presentations were good, and all the judges have keenly assessed the sessions, and correct result actually we got. And congratulations once again to all the best oral presenters. Thank you once again. Thank you for joining. And I request all the participants to have some patience. We will mail your certificates to your ID soon, but we have to work on that. So please have some patience. And the link for this feedback is shared in this chat box, and I'll mail to you also. Please fill this feedback form. It is compulsory for us, compulsory to all of us. So thank you so much. So
thank you. Take
Thank you, madam.
care, sir. Thank you, Sharma sir.
Thank you. Thank you.
Thank you, everyone. Thank you.
Please open the camera for photo session.
Yes. All
Yes.
of you, please.
All of you. Thank you, ma'am, and thank you all.
Thank you. Goodbye.
Goodbye. Thank you.
Photo session is completed. Thank you. Correction? Complete with?
Oh, okay.
Okay. Thank you, ma'am. Photo session is completed. Bye-bye, ma'am. All participants can leave. Your mic.
हिरवानी
जी,
सर,
yes, ma'am.
हाँ, ये 2 लिंक
जी,
हैं
जी,
क्या?
मैम,
फीडबैक के 2 लिंक हैं क्या?
नहीं, both are same, ma'am.
सेम एक ही लिंक है?
Yes, ma'am. One is the first form of the second.
Sir, please share it in the group. Save
Yes,
me
ma'am.
link. Why I have not saved the link so that I can mail to the participants.
Yes, ma'am.
हाँ,
Yes,
okay.
ma'am. Okay. Thank you.
ठीक है सर, मैं लीव कर रही हूँ. Okay, Soeb, bye.
Thank you, ma'am.
Okay then, bye.